All right, so this is my build here that I'm working on. And I want to give a little bit of a tip to anybody who's building their own entire Victron systems. So, working for the phone company for 35 years as a communication technician, the something called Bell System Practices, which was extraordinary for the time. I think it started more than 100 years ago, and there was a lot of people in the Bell system that were extremely smart about how to do things, and how to do things in a procedure that made it the most reliable, even to the point where it was like nuclear tested for blast radius and things like that. But it's amazing what you picked up from the Bell system. And when I worked for the Bell system, I used to work in the power group, and we'd have meetings in which we would have procedures and how to do stuff. And one of the things that I picked up is every single thing in the phone company works off of 48 volts DC power. And this DC power is an extremely powerful way to run the equipment, because it keeps a standard of everything being DC controlled. And then the inverters would simply just turn everything to DC controlled, but they were able to use batteries for backups and things like that. But some of the cables that were connected in these backup systems and something called BDFBs were extremely reliable, with an A and a B power source. And one of the details that I picked up was, because of so many different dissimilar metals used for things like copper, and then maybe brass, and then you have other things like possibly just metal and copper. But all of the metals mean that electrolysis happens. And it happens over years, and you'll see it the most like in batteries, where you have that green fuzzy garbage coming out of your battery top. It's because of the connection, the relationship between metals, and how metals react to each other. And they don't always make the best of contact, because they are dissimilar metals, and no matter how much you clean them, they will not make the best of contact. So in comes the phone company's solution to this, because everything's DC powered, is to use a dielectric that is conductive. And what that means is they used this thing called NOx. And I always wondered why we use this, but now I see, with all of the different metals and the electrolysis that we see in the field, that you see all this green garbage, or fuzzy stuff. It looks like where you have to clean the batteries. Eventually it gets so bad that the connection actually goes bad, and you lose the connection. So the phone company used this really old company called NOx, and it dates back to this family that runs it out of Illinois. They've been doing it for 100 years. I'm sure it's just automated at this point. But I bought some of this stuff. It's called dielectric grease, NOx, and it's really in this white container. But its purpose is to make two different dissimilar metals come together and have the best connection possible. It also will ward off things like fog or marine grade salt. It'll keep those two connections the best they can possibly ever be. So it's called a company called Sansham. It's called NOx A Special, and this is stuff that the Bell system's been using for almost 100 years. It's absolutely amazing. The jar has it looks like this goop that's kind of like this brown stuff, and then you simply just run a light film of anything that you're connecting, and it makes the ultimate connection without any kind of problems at all. You don't need to glop on a lot of it. You just coat this grease over your terminals of where it makes the connection between two dissimilar metals, and you will have the absolute stunning ability to maintain this connection over a lifetime without having any fuzzies, I call them fuzzies, show up, or any dissimilar metals, or anything show up. But it really works really great, and I highly recommend it. I'm really surprised that a lot of people don't use it in this fan building industry, because I think that nobody really knows about it. But what a tip! Let me tell you. Every crimp connection gets this stuff inside the crimp. You just a light coating of on the strands, and then you put your crimp connector on it, and then underneath that, and then you lightly coat every blade that goes onto another piece of metal, just a light coat of this. So it's good that you should clean your terminals with alcohol, such as Nate recommends from Explorus. But afterwards, I put this stuff on, just a very light coat, and don't glop it on because it is conductive, and it's so don't you got to be very careful and make sure that you put it only on the connector spots and not on don't glop it on because it will arc if it doesn't. So anyways, one of the greatest tips in the van business, and this is also used in the marine industry quite heavily because of it's resistant to salt. This will definitely last a lifetime as far as good stuff. So just wanted to put that out there as a possible solution for a lot of people who were looking at just starting their Victron builds. Thanks.